last breakdown, we looked at Agent 7, the tool using agent. By implementing the think, plan, act loop, we gave a single cognitive core the ability to select external tools, execute them, and recover from basic errors. That architecture took an isolated brain and gave it a pair of hands. It could parse intent, pull a lever, and check its own work. But scaling that complexity creates a structural ceiling. When you ask that same agent to read SEC filings, parse Twitter sentiment, and run financial models simultaneously, the system breaks down. You force too many disparate data streams into a single prompt, and the context window shatters under the weight of competing instructions. This brings us to Agent 8, the Chain-of-Agents Orchestrator. Looking at the system hierarchy, we are firmly in the tools and orchestration tier. If Agent 7 gave a single brain a pair of hands, Agent 8 replaces that single brain with a highly coordinated team of specialists. We reach a point where task decomposition and specialized reasoning outperform a million-token context window. When a single agent handles too many tasks, it suffers from context dilution. Its attention is divided across overly broad instructions, which degrades its focus on any single variable. Take market intelligence. If you instruct one agent to analyze a company's balance sheet, read the latest news headlines, and gauge social media sentiment, it has to juggle entirely different reasoning policies at once. This leads directly into an engineering anti-pattern known as the consensus trap. When forced to process conflicting data, a single generalist agent tends to generate a compromised summary. If the financial data is sharply bullish, but the social media sentiment is aggressively bearish, the agent mathematically averages them. You get a flat gray line. The severity of both signals is erased, leaving you with useless noise. In complex research, that contradiction isn't an error. The disagreement between the stock performance and the public perception is a critical signal that must be captured. The engineering challenge is to build a system that can surface and measure these contradictions, rather than silencing them. System intelligence depends on the ability to isolate and measure variables before they interact. Solving the consensus trap requires moving from a single generalist to a coordinated relay team. At the top of the structure sits the manager agent. Crucially, the manager does zero analysis. Its function is to interpret the user's goal, break it into subtasks, and manage the team's dependencies. Below the manager are the specialists. These are micro-agents with narrow roles, specific tool access, and entirely isolated context windows. By routing financial data to a financial agent and news to a news agent, streams remain pristine. They are analyzed in isolated inspection environments. This specialization prevents conflicting data from blending into noise during the initial processing phase. This diagram maps the complete six-stage workflow of the Chain-of-Agents Orchestrator. Step 1 begins with the manager agent receiving the prompt and decomposing the objective into independent assignments. Step 2 activates the specialist team. The news, financial, and sentiment agents run in parallel, executing assigned tasks using their own toolsets. Step 3 is the typed protocol. This is the wire layer, built on standard model context protocol and agent-to-agent specifications. Instead of passing raw conversational text, agents communicate strictly through a standardized JSON envelope. Every message requires a declared sender, recipient, task ID, and status field. Step 4 is shared memory. Rather than maintaining separate, disconnected histories, the team relies on this central node as the single source of truth. It splits into 3 layers. First, a working scratchpad. Second, an episodic logbook. Third, a durable semantic memory. In Step 5, synthesis, the manager agent pulls the isolated outputs back from memory to assemble the final report. This leads to Step 6. If the manager detects a discrepancy between findings, it triggers the conflict resolution mechanism. The system runs semantic similarity analysis on competing reports. If the score drops below 0.7, a conflict is formally flagged. Conflicting claims are routed to a specialized arbiter agent. It consults a knowledge base, evaluates competing data, and produces a proposed resolution with a calibrated confidence score. If that score exceeds 95%, the decision is accepted. But if the arbiter fails to reach high confidence, the system immediately routes the decision to a human reviewer. Human review is engineered into this architecture as a deterministic branch of the logic tree. It is a planned safety net for high-stakes ambiguities. To see how this protocol operates in practice, we can trace the Python implementation driving the manager agent. The manager decomposes the task in code using a delegate-and-collect methodology. It iterates through a dictionary of registered specialists, sequentially dispatching the target company name to each one. Regardless of what external API they call, every specialist returns information using an identical dictionary structure, providing a source, a status, and the data payload. As each specialist reports back, an append function writes a time-stamped record of their status and data summary directly into shared episodic memory. Once memory is populated, the manager calls its synthesize report function. It extracts the sentiment score and stock percentage change, calculating the absolute difference to generate a conflict score. If this score exceeds 0.5, the system forces a human escalation warning. The code transforms abstract textual disagreement into a quantifiable, routable, and safe metric. These fixed protocols are the foundation for enterprise systems like DevOps triage, multi-source market intelligence, and continuous software testing pipelines. However, this architecture has a limitation. The Chain-of-Agents Orchestrator operates on a predefined team roster and a fixed communication protocol. It does not dynamically self-assemble its team based on the query. If a specialist isn't explicitly registered in the manager's dictionary, it cannot be deployed. This rigidity ensures the reliability and predictability required for more complex evolutionary steps in AI architecture. Once you have a team that can execute and resolve conflicts reliably, you can embed that team into long-running business processes, a pattern known as agentic workflows, which we cover in Agent 9. This orchestrator architecture is drawn directly from Chapter 7 of 30 Agents Every AI Engineer Must Build by Imran Ahmad. You can find the book on Amazon and Pact, with additional engineering resources at neuralsca. By quantifying disagreement, this architecture ensures critical signals aren't lost to context dilution or model averaging.